Hello, my name is Alexander, and I'm presenting a project of the hip joint endoprosthesis head design improvement. A typical design of an artificial human hip joint usually consists of four main parts: two implants in the pelvis and thigh bone, as well as a liner and a head attached to them, which form the joint. The idea is to make such a head multilayered. Endoprosthesis is performed for severe arthritis of the joints, fractures, as well as revision, repeated operations to replace worn or loose implants. The operation completely eliminates pain and restores the patient's ability to move independently. It is the most common among elderly patients in the treatment of fractures where the bones have lost the ability to fuse independently. It is also used in the treatment of severe comminuted fractures resulting from road accidents or warfare. Currently, solid heads made of biocompatible metal alloys and ceramic are used. The main disadvantage of metal femoral ball heads is the high level of wear products, as well as the release of metal ions due to corrosion. In the future, this leads to inflammatory process and loosening of the implant. Ceramic heads don't have such disadvantages, but due to the imperfection of the design, they are prone to sudden destruction, which immediately immobilizes the patient and causes acute pain. We propose to solve this problem by using a combined multi-layer head. The outer layer is made of ceramic, which is currently the best solution in terms of friction, and the core is made of metal. This will ensure the correct distribution of force stresses in the ceramic layer and facilitate the connection of the head with the femoral implant stand. Such a design will increase the service life of the endoprosthesis, reduce the risk of unpredictable destruction, eliminate the need in additional intermediate caps, and probably open up the possibility of repairing used heads by restoring the mounting hole. The difficulty in manufacturing is filling the spherical inner surface with metal, and there is our main challenge. Regarding the market situation, there are 11 key companies competing with each other. Based on economic survey reports, the market for hip arthroplasties is estimated to be worth about $5 billion in 2021 and will continue to grow so that it could double in size by the end of the decade. 1/10 of this market belongs to femoral ball heads. The marketing strategy is variable in accordance with the scale of production and is initially focused on piece production to the patient's order. Then it's planned to cooperate with government agencies and move to the supply of heads to large manufacturers of endoprosthesis. The market value of competitive offers varies in wide ranges, and for ceramic femoral ball heads ranges from $150 to $850 and even higher, depending on the class of ceramic, brand, cooperation of the clinic with the manufacturer, and other factors. It's expected that variable costs in the production, such as consumables, ceramic blanks, labor, equipment operating time, will be up to $50 per one head, and the volume of production at the initial stage will be limited by the demand for the product. However, with favorable demand, fixed assets will be able to pay off in 2 years. Currently, the working conditions and layout of the hip joint head in the human body are being studied. A patent for a utility model was also obtained, but the key factor in protecting intellectual property is still the know-how in the technology of filling a ceramic shell with metal. The project team is headed by Professor of the Department of Laser Technologies Leonid Golovko. Docents Alexei Kohlyak and Mikhailo Bleshitsyn are responsible for the financial and marketing components. To start research, the project lacks equipment, the cost of which is up to $60,000. The lion's share is occupied by the laser radiation source. Also, a 5-axis coordinate table with numerical control, a powder dispenser, and of course consumables with ceramic blanks are needed. Part of the funds will go to the development of a laser focusing and powder supply system for laser cladding in hard-to-reach conditions. Thank you for your attention. Have a nice day.